There is one question in the UAP mystery that almost sounds impossible. Not whether something was seen, but whether something could be hidden in plain sight. For decades, UFO witnesses have described objects appearing suddenly, vanishing instantly, fading from view, blinking out of the sky, or seeming to shift between visibility and invisibility. Pilots have reported targets that appear on sensors, but not to the eye. Witnesses have described lights that vanish without obvious movement. Military videos show objects that are difficult to interpret because distance, scale, heat, and motion are all uncertain. And in the modern UAP era, the mystery has moved beyond a simple question of what did someone see. Now the question is deeper. What if the problem is what we are capable of seeing? What if some UAP reports are not just about strange objects, but about the limits of light, perception, sensors, materials, energy, and physics itself? Today we're not claiming that UAPs are invisible spacecraft. We're not claiming that quantum physics proves UFOs, because it does not. But we are asking a serious question. Could the physics of invisibility help us understand why some UAP cases remain so difficult to detect, classify, explain, or dismiss? Welcome to UFO to UAP Explained. I'm your host Matt Tones, and today we investigate UAPs and the physics of invisibility, quantum physics, cloaking, and the limits of what we can see. Let's begin. The word invisibility belongs to science fiction, but the science behind visibility is very real. To see something, light has to interact with it. Light must reflect, scatter, absorb, emit, or pass through it in a way that reaches the eye or a sensor. That means visibility is not just about the object, it is about interaction. An object is visible because electromagnetic radiation interacts with it. A radar system detects something because radio waves interact with it. An infrared camera detects heat because thermal radiation reaches the sensor. A satellite records an object because light, heat, or another signal is captured from above. So when something is invisible, it may not mean it has vanished. It may mean it is not interacting with the detection system in the expected way. And that distinction matters. A stealth aircraft is not invisible. It is engineered to reduce detection. A submarine is not invisible. It is hidden by the environment and by sensor limitations. A black object at night is not invisible. It is simply hard to distinguish from its background. A transparent object is not magic. It allows light to pass through it in a particular way. So when we talk about UAP invisibility, we need to be careful. There are many possible meanings. Invisible to the human eye, invisible to radar, invisible to infrared, invisible to optical cameras, invisible until viewed from a certain angle, invisible because it is too small, too fast, too distant, too dim, or too close to the background, invisible because the sensor is not designed to detect it, or invisible because something more exotic is happening. The first step is not to jump to quantum physics. The first step is to ask, invisible to what? Question for you. When a UAP is described as appearing or disappearing suddenly, do you think that suggests advanced technology, sensor limitation, perception error, or something else entirely? Drop your answer in the comments. Now let's talk about quantum physics. Quantum physics is one of the most misunderstood areas in the UFO conversation. It is often used as a shortcut. People say quantum when they really mean mysterious. Quantum field, quantum portal, quantum consciousness, quantum craft, quantum dimension, quantum invisibility. But using the word quantum does not make an idea scientific. Quantum physics is not magic. It is the branch of physics that describes matter and energy at a very small scale. Atoms, electrons, photons, fields, probabilities, and interactions that do not behave like ordinary objects in everyday life. Quantum physics is real. It powers modern technology. Lasers depend on quantum principles. Semiconductors depend on quantum physics. MRI machines, atomic clocks, GPS corrections, quantum sensors, and modern electronics all connect to quantum theory. But that does not mean large objects can simply vanish, teleport, or phase through reality because someone invokes the word quantum. That is the line this episode needs to hold. Quantum physics may help us understand the deep structure of light, matter, and measurement, but it does not automatically explain UAP. The question is not, can we attach quantum language to UFO claims? The question is, are there known areas of physics, quantum optics, metamaterials, stealth, plasma, electromagnetic fields, or sensor interference that could help explain why some things are difficult to detect? That is a more serious question, and it begins with light. Light behaves both like a wave and like particles called photons. When photons interact with matter, they can be reflected, absorbed, transmitted, scattered, refracted, or even emitted. Everything we see depends on that interaction. A red object looks red because of how it absorbs and reflects different wavelengths of light. A mirror reflects light in an organized way. Glass lets much visible light pass through. Fog scatters light and hides distance. A hot object emits infrared radiation. A radar target reflects radio waves. In other words, visibility is wavelength dependent. Something visible in one part of the electromagnetic spectrum may be invisible in another. A stealth aircraft may be hard to detect on one radar band, but more visible in another. A warm object may stand out in infrared, but not in visible light. A transparent object may be visible because of distortion, reflection, or shadow. A dark object in space may vanish optically, but still be detected by heat or radar. So in UAP research, invisibility is not one problem. It is a spectrum of problems. What wavelength are we using? Visible light, infrared, radar, ultraviolet, radio frequency, satellite imagery, magnetic measurement? If an object is hard to detect in one band, the serious question is whether it appears in another. This is why modern UAP investigation increasingly depends on sensor fusion. One sensor can mislead. Multiple sensors can build a stronger picture. If something is invisible to the naked eye but visible on radar, that matters. If something is visible optically but absent on radar, that also matters. If something is visible in infrared but not in visible light, that matters. If it appears only on one sensor, that raises a very different question. Is it a real object, a sensor artifact, a reflection, a software issue, a temperature contrast, a classified aircraft, a drone, a balloon, atmospheric plasma, or something still unresolved? The future of UAP evidence depends on comparing these channels. That is where the physics of invisibility becomes practical, not as fantasy, as detection science. Now let's talk about cloaking. In popular culture, a cloaking device makes an object disappear. In real science, cloaking is much more limited and much more interesting. One approach involves metamaterials. Metamaterials are engineered materials designed to interact with electromagnetic waves in unusual ways. The idea is not magic, it is structure. By designing material structures smaller than the wavelength being manipulated, researchers can influence how waves move around or through an object. In theory, a material could guide certain wavelengths around an object so that the waves emerge as though the object was not there. That is the basic idea behind some invisibility cloak research, but there are major limits. A cloak may work only for a narrow wavelength. It may work only from certain angles. It may work only for small objects. It may work only in laboratory conditions. It may not work across visible light, infrared, radar, and every angle at once. It may require materials not practical for aircraft. It may introduce distortions that make the object detectable in other ways. So the existence of metamaterial cloaking research does not mean operational invisible UAP exists, but it does prove something important. The idea of manipulating detection is not purely fictional. Modern science already studies how waves can be redirected, absorbed, scattered, and also controlled. That matters because UAP investigation is partly about waves, radar waves, light waves, infrared radiation, radio signals. If advanced human technology, foreign systems, experimental materials, or unknown phenomena are involved, the detection problem becomes central. What is the object doing to the waves we send toward it? What is it emitting? What is it absorbing? What is it reflecting? What is it hiding? Question for you. Would you consider a UAP case stronger if it appeared on some sensors but not others? Or would that make you more suspicious of sensor error? Tell me your thoughts in the comments. Now let's move deeper into quantum physics. At the quantum level, measurement is strange. Particles do not behave like tiny billiard boards. Quantum systems can exist in superpositions where possible states are described mathematically until measured. Entanglement can link quantum properties across separated systems in ways that challenge ordinary intuition. Photons can interfere with themselves. Electrons can behave like waves. The act of measurement changes what can be known about a system. And this is where people often make the leap. They say, if quantum physics is strange, maybe UAP invisibility is quantum. But that is not enough. The fact that quantum physics is strange does not mean every strange event is quantum. Most objects in the sky are not behaving as isolated quantum particles. Aircraft, drone, balloons, satellites, meteors, and atmospheric phenomena are macroscopic systems. They are large enough that ordinary physics usually dominates their visible behavior. So if someone claims a UAP is using quantum invisibility, we need to ask, what does that mean? What measurable effect is being claimed? Is light being bent? Is radar being absorbed? Is the object changing its thermal signature? Is it manipulating the electromagnetic field? Is it producing interference? Is it using materials with unusual optical properties? Is there data across multiple wavelengths? Without a measurable claim, quantum invisibility is just a phrase. But there are quantum technologies that matter to this discussion. Quantum sensors may become important in future detection. Quantum magnetometers can measure extremely small magnetic fields. Atomic clocks can improve timing. Quantum communication and quantum radar concepts are being explored in research settings. Quantum imaging techniques may improve low light detection or measurement sensitivity. Again, this does not prove UAP, but it means quantum technology could become part of how future UAP research is conducted. The quantum side may not be the object, it may be the instrument. That is a powerful shift. Maybe the question is not, are UAP using quantum physics? Maybe the better question is, will quantum sensors help detect what older systems miss? That is a serious research question. If UAP cases involve subtle magnetic effects, electromagnetic anomalies, unusual light behavior, or weak signals buried in noise, then better sensors will matter. Quantum science may not explain the phenomenon, but it may improve the measurement of the phenomenon. And measurement is where real investigation begins. Now, let's talk about invisibility and stealth. Stealth is not invisibility, it is signature management. Modern stealth technology tries to reduce radar reflection, infrared signature, acoustic signature, visual detection, and electronic emissions. A stealth aircraft does not disappear. It reduces the chance that specific systems will detect it, identify, or track it. This is important for UAP analysis because some reports may involve classified technology. If a military observer sees something unusual, one possibility is that the object is not non-human. It could be a test platform, a drone, an adversary system, a sensor target, a decoy, a classified aircraft, a high-altitude balloon, a reconnaissance platform, or a combination of aircraft and sensor confusion. That possibility has to be taken seriously. In military environments, the public may never get the full answer because the answer may involve classified capabilities. This creates a difficult loop. If the object is secret human technology, officials may not explain it. If the object is unknown, officials may not be able to explain it. If the sensor data is classified, the public cannot judge the evidence. The result is uncertainty, and uncertainty is where UFO mythology grows. So when we talk about invisible UAP, one category is not exotic physics, it is national security. Some things are designed not to be seen. Some things are designed not to be tracked. Some things are designed to confuse sensors. And some government explanations may remain vague because the detection systems themselves are sensitive. That does not mean all UAP are secret aircraft. It means secret aircraft and sensor systems must be part of the analysis. The show's position remains the same. What does the evidence actually support? Now let's talk about apparent disappearance. Many UAP reports include sudden vanishing. A light is there, then it is gone. An object appears, accelerates, disappears. A radar track is present, then drops. A shape is visible, then lost. There are ordinary explanations for some of this: distance, angle, lighting, cloud cover, camera exposure, sensor tracking limits, object speed, atmospheric distortion, a drone turning off lights, a satellite entering Earth's shadow, a meteor burning out, an aircraft changing direction, a balloon losing illumination, a radar track being lost because of range, angle, clutter, or processing. So sudden disappearance is not automatically evidence of invisibility, but it is still worth examining. The key question is, did multiple independent systems lose the object at the same time? If a witness loses sight of an object, that is one thing. If radar, infrared, optical, and radio frequency systems all lose it simultaneously, that becomes more interesting. If the object vanishes visually but remains on radar, that suggests one category. If it vanishes from radar but remains visible, that suggests another. If it disappears from all systems at the same location and time, that raises a stronger question. But again, we need to see the data. UAP research lives or dies on data quality. This is why sensor metadata is so important. Where was the camera? What was the lens? What was the range? What was the field of view? What was the sensor mode? What was the radar band? What was the target angle? What was the weather? What else was in the airspace? Without those details, disappearance becomes storytelling. Without those details, it becomes analysis. Question for you. What would you need to see before you accepted that a UAP did not simply leave you, but actually became undetectable? Drop your answer in the comments. Now, let's consider a more speculative but fascinating possibility. What if some UAP are not solid objects? This is where plasma theories, electromagnetic fields, and optical effects overlap with the physics of visibility. A plasma can glow, it can interact with magnetic fields, it can emit radiation. It may produce unusual visual effects. Atmospheric electrical phenomena may appear strange, move unpredictably, or be difficult to classify. Some official and scientific discussions have considered whether certain luminous aerial phenomena might involve plasma-like processes. That does not explain every case. It may not explain the strongest cases, but it matters because a plasma-like phenomenon would change the way witnesses interpret the event. A person might see structure where there is light. A sensor might detect heat or radiation. A radar system might produce confusing returns. The event might appear, change shape, or vanish. Again, this does not mean plasma is the answer. It means the category of object may be too narrow for some cases. The sky contains aircraft, but it also contains fields, particles, radiation, weather, atmospheric electricity, reflections, optical illusions, ice crystals, satellites, drones, balloons, and sensor artifacts. Some UAP may be things, some may be events. That distinction matters. A craft has a surface. An event may be a temporary interaction. A craft travels. An event forms and dissipates. A craft reflects light. An event emits light. A craft has an origin point. An event may emerge from conditions. If we mistake an event for an object, we may ask the wrong questions. Where did it fly from? Who built it? What was its propulsion? But the better questions might be, what atmospheric conditions produced it? What electromagnetic processes sustained it? What sensors detected it? Why did it appear in that location? Why did it vanish? This is one of the reasons UAP research needs scientists, not only intelligence analysts. It also needs humility, because the unknown may not fit the categories we bring to it. Now let's return to quantum physics again. Could quantum effects create invisibility at a large scale? In everyday conditions, quantum effects usually do not allow large objects to simply disappear from observation. A large object interacts with its environment constantly. Photons hit it. Air molecules collide with it. It emits heat. It reflects light. It disturbs airflow. It occupies space. To hide a large object, you would need to manage many interactions at once. Visible light, infrared radiation, radar, shadow, heat, sound, electromagnetic emissions, air displacement, background distortion. That is extremely difficult. So if someone claims quantum invisibility for a large UAP, the burden of proof is also very high. We should not dismiss radical ideas because they sound strange, but we should demand evidence equal to the claim. What was measured? What wavelengths were affected? What energy source would be required? What physical mechanism is proposed? What signature would the mechanism leave? Could the effect be replicated? Could independent scientists test it? Those are the questions that separate serious speculation from fantasy. The UFO field does not need more vague quantum language. It needs testable quantum questions. For example, can advanced sensors detect weak optical distortions? Can quantum magnetometers detect unusual field changes during aerial events? Can improved timing networks correlate sightings across distant sensors? Can low-light quantum imaging improve detection of faint aerial objects? Can metamaterial research inform how stealth systems might appear across different sensors? Those are grounded questions. They do not claim too much. They open a path to better evidence. That is the tone this subject deserves. Not quantum proves UAP are interdimensional, but quantum science may expand what we can measure, and measurement may change what we understand. Now let's look at this from the perspective of a future UAP investigation. Imagine a strange object is reported near restricted airspace. A pilot sees something flicker and disappear. Radar detects an intermittent track. An infrared system sees a brief thermal signal. An optical camera captures only a distortion. A radio frequency monitor records unusual emissions. A magnetometer registers a small local anomaly. Weather data is normal. Known aircraft are ruled out. Satellite passes are checked. Drone activity is checked. The raw data is preserved. Now investigators have something interesting. Not proof of aliens, not proof of quantum invisibility, but a multi-sensor event involving visibility, disappearance, electromagnetic signal, and possible field disturbance. That case would deserve serious review. It would also show why invisibility should not be treated as one idea. The object may be hidden optically but not electromagnetically. It may be visible thermally but not optically. It may reflect radar poorly but emit infrared. It may appear and disappear because it is not a solid craft but a transient phenomenon. Or it may be a classified system designed to confuse multiple forms of detection. The evidence would not answer the question immediately, but it would tell us what kind of question we're dealing with. That is the future of UAP research. Not one witness, not one clip, not one dramatic phrase, but layers of measurement. Question for you. Do you think the next breakthrough in UAP research will come from better government transparency, better sensors, or better physics? Tell me in the comments. Now, let's talk about public trust. The problem with invisibility is that it easily becomes unfalsifiable. If someone says the craft was invisible, the data was hidden, the sensor could not detect it, the government knows but cannot reveal it, the technology is beyond physics, then how do we test that? A claim that cannot be tested may be interesting, but it cannot become evidence. That is why serious UAP research must resist the temptation to make invisibility a catch-all explanation. Every claim should leave a trace. If light is bent, there may be optical distortion. If radar is absorbed, there may be a radar signature pattern. If heat is hidden, there may be a thermal contrast. If electromagnetic fields are involved, there may be measurable field effects. If a sensor fails, there should be logs. If a craft accelerates, there should be trajectory data. If a physical object moves through air, there may be environmental effects. The future of the topic depends on testability. This is where quantum physics can either help or hurt the conversation. It helps when it gives us better tools, better sensors, better clocks, better imaging, better understanding of light and matter. It hurts when it becomes a word used to avoid evidence. The show will always choose the first path. Evidence before conclusion. Measurement before mythology. Science before certainty. Now let's bring this together. UAPs and invisibility is not a question we can answer with one theory. There are several possible layers. The first layer is perception. Humans may miss things, misjudge distance, or interpret ambiguous lights as objects. The second layer is sensors. Different systems detect different parts of reality, and each has its limits. The third layer is stealth. Human technology can reduce detectability and create confusion. The fourth layer is atmospheric physics. Some phenomena may appear, glow, shift, or vanish because they are events, not craft. The fifth layer is advanced materials. Metamaterials and wave control research show that detection can be manipulated under specific conditions. The sixth layer is quantum science, not as magic, but as the deep physics behind light, matter, measurement, and future sensor technology. And the final layer is disclosure, because the best evidence may be tied to classified systems, and the public may only see fragments. That is why UAP invisibility is not just a physics question, it is also a government transparency question. If something appears only on classified sensors, who gets to evaluate it? If an object is invisible to the public but visible to military systems, what can be released? If the explanation involves classified technology, how much truth will the public ever receive? If the explanation is unknown, how do officials admit uncertainty without creating panic or speculation? These are the questions that make UAP disclosure so difficult. Now, here is the final point. The physics of invisibility does not make UAP easier to explain. It makes them harder to oversimplify. A thing can be real and misidentified. A sensor can be accurate and still incomplete. A witness can be sincere and still mistaken. A craft can be advanced and still human. A phenomenon can be natural and still poorly understood. A case can be unresolved without proving extraordinary origin, and quantum physics can be relevant to measurement without proving quantum spacecraft. That is the balance we need. Curiosity without overclaiming, skepticism without dismissal, science without sensationalism, disclosure without mythology. Because the future of UAP investigation may not depend on whether something is visible to us, it may depend on whether we have built the right systems to detect what visibility alone cannot reveal. Final question for you. Do you think the idea of UAP invisibility makes the subject more credible, more speculative, or more scientifically interesting? Leave your answer in the comments. This has been UFO to UAP Explained. I am Matt Tones. If you found this episode valuable, follow the show, share it with someone interested in UFO disclosure, UAP science, quantum physics, invisibility, stealth technology, sensor fusion, Arrow, NASA, and the future of unexplained aerial phenomena. And remember, the unknown may not always be hidden. Sometimes we simply have not learned how to see it.